Hello guys, this is for grade 12. Today we start the new unit after we finished the unit test from yesterday, and I'm sending your marks soon. Now I will start explaining this unit by video, by another, and so on. We will take it step by step, and I want you to follow me on Engage, so that's how you can watch the explanation and also get the assignments to cover both at the same time. This unit is not easy, but we will try to make it easy as much as we can. It is, if you remember, I told you this is about the electronic configuration or the electronic structure. You have taken long time ago the very easy structure. The first level, second energy level takes 2 electrons, second one takes 8, and so on. And this was not, let's say, not your age. In your age, you have to know what is the electronic, real electronic configuration or the deep electronic configuration. Okay? So I will start here with the notes, the study notes. It will be available on Engage. As you see, this unit is about the electronic structure. Okay? So in the beginning, we will start with some simple definitions, then some very important historical background until we reach the idea of electronic configuration and why this happened and why do we use this way, why did we discover this method, and so on. So now, as usual. Okay. So within this unit, in the electronic structure, I'm explaining the models that involves electrons, the electron, Bohr model, and the waves, or what we call the dual nature property. We will speak about the quantum mechanical theory. Then on the other side, we will see electrons in the atom, the energy levels, and the electron configuration or structure. We have to start with these definitions and historical background. Then after, we go to the other stuff. Okay? So now let's see. You start from page 214, as you see here. Now, the very important definitions we have: electron. Electron is, put more larger so that's how you can see. Okay. So electron is a small subatomic particle found outside the nucleus of an atom. We all know that. So the mass, if you remember, we said in the other unit, it is very small that we neglect the atom if you compare it with the proton and the neutron. So it's very small. You don't need to know this number. It's a constant number of the mass of the atom. It is of the electron. It's 9.11 times 10 power negative 28. And it is 1 over almost 2,000 of the mass of the proton, or 1 over 1,836. The charge of the electron is negative charge, as you know, okay? And in coulombs, if you remember this unit from physics, the unit of charge, it's negative 1.6022 times 10 power negative 19. Even we give you here the radius of the electron, it is 2.8 times 10 power negative 15, which is very, very, very small. Okay. When you remember this also from physics, that the electric current, electrons moving from one place to another, protons and neutrons remain in the nucleus. I think this was clear when we said electrons are the factor that are causing all the phenomena we know, because they move. Protons and neutrons cannot move from one place to another, but electrons can flow from one point to another. Okay. And you know this definition, ion, we have taken this last unit, it is an atom that gained or lost an electron, and there's a positive ion, negative ion, if the atom gains electrons, which is negative, so it makes it a negative ion. Or if it loses electrons, it will be losing negative charge, which makes it a positive ion, and so on. Okay, these are very simple introduction to the electron and its properties. So this is something just to know. Okay? Now, the historical background of this unit. Okay, the scientists noticed that if you expose some gases, and we take gases as a simple state of matter, if you take any gas and you take this gas and expose this gas to very high voltage of electricity, there is something very weird happens. We found that the particles of gas give some kind of light, or what we call spectrum, which is very strange. If you expose a gas to light, and this, we use something like that. If you remember, I explained the cathode tube, okay, from J.J. Thomson experiment. Now we are using this application of if you expose some gases to some real high voltage, or what we call excitement, some of, excitement, this leads to a spectrum. Okay, so now this spectrum was discovered, then many explanations came after. The best one is the Bohr explanation. Let's watch this video. This will give you a good idea about okay. I'll switch off the light. I'll put you the link of this video on Engage, so you can watch the spectra produced by electric charging gases and vapors. If you expose gases into very high voltage, this leads to some lights. They because of the excitement of the atoms. And let's see what happens here in this experiment. Okay, now the guy is connecting the high voltage source and we get low pressure gases under very low pressure, and it's vacuumed where nothing inside except for the gas. And we connect the tube, as you see, this is one of the gas samples. We connect it to electricity source. Once we connect electricity, the gas atoms are excited and they give you this kind of light. Now the guy is watching the light. When he switches off everything, he sees the light very clear. You see different colors of the gas of bromine, for example. It doesn't give one color. You can see it with your eye, one color. But if you see this through a telescope, you can see there are different colors where you see it one color, which is very strange. Now, this was bromine. Now, another sample of another gas. Watch what happens. It's hydrogen, as you see here, hydrogen cyanide. Hydrogen cyanide gas, and this is what you see with your eye, but this is what you see. This is ammonia, another spectrum. And we found that every gas has its own print, like water vapor. Each one of them has its own print of spectrum. Hydrogen chloride. Argon gas. Ether. Okay, very good. So what you have seen here, okay. So the scientists they couldn't understand why this happens until Bohr came and gave us an explanation about what happens with some other scientists for the simplest atom we know, which is hydrogen. Okay, so that's why we call this the Bohr model of the hydrogen atom. So the atomic theory, and we have made some assignment, except for Hatem, you didn't send the assignment. We did some assignments on the atomic theory and the historic or the timeline of the atomic theory. Now, what we will study in this unit, the quantum theory, the early quantum theory, and what is the idea of quantum and quanta, and how did Bohr explain the idea of these spectra or the spectrum of hydrogen, why this happens, why these colors. We have to understand. Bohr helped us to understand this. Okay, so the Danish physicist Niels Bohr, I'm sorry, I have to switch on the light. So in 1913, Danish physicist Niels Bohr, he combined the atomic spectroscope with the spectroscope. You have seen this in the video, the guy was using the spectroscope to watch the spectrum of each gas. So the quantum theories into a single theory. He gathered all the ideas in one strong model, and this was his model. It's very simple. The man said, if the atom is made of a nucleus in the center and electrons in the energy levels, the man noticed if we give this first energy level n equals 1, or level number 1, level number 2, and level number 3, what happens that when the hydrogen gas is exposed to very high voltage, the atoms get excited and the electrons inside these atoms will start jumping. When they gain more energy, they will start jumping to a higher energy level. And a higher energy level will, if you jump from this level to the next level, because now you have more energy, so you can run in a bigger track. So when you go in the bigger track, by running, you will feel exhausted. You lose energy. So Bohr said losing this energy comes in the form of photons, and these photons they form light. So that's why when you get a hydrogen gas or any gas excited, the electrons can move from low energy levels to high energy levels, and on the way back they lose this energy in the form of photon, and these photons, they give you these lovely spectra or print spectrum of each one. And so it's very simple. So these lights we see, they come from the photons that the electrons lose when they move from an energy level to another. There are some equations here for some other scientists like Bohr, like Rydberg, another physicist who helped in the quantum theory. I want you just to understand the idea. You can read the background, but this is not the core of the unit. Okay, so I will stop here at the quantum mechanical model of the atom, and I will continue explaining next time starting from here. Thank you. Have a good one. Take care. Stay safe.